Good morning class, this is Mr. Z. Today we will be doing complex numbers review for your asynchronous workday. Complex number review. So let's take a quick number. We'll start with a number in focus and we will build up from it. So the number in focus for us right now is 1 plus 2i. Let's start working with the real part. This here is your real part, while 2i is the imaginary part. Now you might be thinking, how do we graph this? So for a graph, it looks completely similar to a real graph, except the fact that complex graph has a real numbers on the x-axis and imaginary numbers on your y-axis. As always, the origin is always here. Now the number in focus is 1 plus 2i. Let's draw a few here. So this is 1, 2, 3, 1, 2. 1 plus 2i, which means we go 1 on the right or the real axis and 2 up or on the imaginary axis. So in this case we go 1 on the real and 2 on the imaginary axis, which brings us all the way up there, and that is our complex number. Let's name it Z, and this is our complex number Z. Right, that does it with the part 1 of the lesson so far. Now let's take a look at the absolute value. So the absolute value is going to be your square root of the real part squared plus the imaginary part squared. In this case, we will get 1 squared plus 2 squared, which is the square root of 1 plus 4, giving us the square root of 5. And absolute value is represented as r. Likewise, the direction angle, which is represented by theta, is given as the inverse tangent of your imaginary part by the real part, which is going to be the inverse tangent, in this case, of 2 over 1. Now let's take a quick look at the calculator. So the way you do inverse tangent is you do a shift and you do a tan, you do 2 divided by 1, which gives you 63.43 degrees. Again, you do your shift, tan, imaginary part divided by the real part, gives you 63.43 degrees. And that's all we'll do on a calculator for now. Now let's write this complex number in different forms. So as you know, polar complex numbers has 2 different forms. One is the polar form and the other is the exponential form. And also the third form that we already know, the form we started with, this form with a plus bi, it is known as your rectangular form. Our polar form is very simple. You write your complex number with r cosine of theta plus I sine of theta. So in this case, our number 1 plus 2i will be equal to the r, which is square root of 5. Then we have a cosine of 63.4 degrees plus I sine of 63.4 degrees. So this here is our answer in polar form. Now in order to convert the polar form to rectangular form, to exponential form, I'm sorry, all you have to do is you have to write it in this form, I theta. Remember, this comes to us from Euler's formula. So writing this number, r times e power I theta. So our complex number 1 plus 2i in exponential form would be square root of 5 times e power I of 63.4 degrees. And you can convert this into radians as well, but for now we can leave it in degrees. So r e power I theta. Now going back to this number here, we have 1 plus 2i. So we can at this moment perform addition, subtraction and multiplication on these numbers like you would do with any variable. So let's say you want to add your 1 plus 2i with 3 plus 4i. What you would do, you would add the real part, you get 3 plus 1, you get a 4, and you add the imaginary part, 4i plus 2i, you get a 6i. So addition is the same, so is your subtraction. The part we are concerned about here is how you multiply and divide. So before we get into that part, we have to take a look at conjugates. So the number in focus here is 1 plus 2i, and its conjugate is basically the same. All you have to do is take your real part, the imaginary part, and just change the sign. Since this was a plus, the conjugate will have a minus. So the conjugate of 1 plus 2i is 1 minus 2i. Now there's a couple things you can do with your conjugate. First thing, we can add the number with its conjugate. So let's do that. We do 1 plus 2i and we add it to 1 minus 2i. Add the real part, you get 1 plus 1. Then the imaginary part, 2i minus 2i. See how it's a 2 plus 0, which is basically 0. And note the observations, please. So we added a complex number with its conjugate, and we got a real number. There is no imaginary part involved with this. Now let's do the same with multiplication. Let's multiply the number with its conjugate. Do 1 plus 2i with 1 minus 2i. So if you follow your FOIL method on this, first, outer, inner, and last, you will get minus 2i squared, which in this case is going to be 1 squared minus 4i squared. Again, in case I did not say this before, I squared is -1. So using this value of I squared, let's draw a dot, connect up here, we get 1 minus 4 times -1, which gives us 1 plus 4, ending with a 5. Again, as you see this observation here, 5 is another real number. And that's that for part 1 of the video. So to give you guys a quick refresher of what we've done here so far. We started with the complex number 1 plus 2i. The real part was 1. The imaginary part was 2. It was in rectangular form with a plus bi. What we did next is we found out its conjugate by changing the sign of the imaginary part. Then we added the complex number with its conjugate. We got a 2, which was a real number. Next up, we multiplied the imaginary number with its conjugate. Then we got 2 of 5 following our FOIL method, and this was again a real number. So the conclusion here was when you multiply or add a number, complex number with its conjugate, you get rid of the imaginary part. You are only left with the real part. Now going back to converting this complex number into different forms. First, we find out the absolute value by taking the square root of real part squared plus imaginary part squared, which in this case would be square root of 1 squared plus 2 squared, giving us square root of 5. And next up, we have to look at the direction angle of a complex number, which is given by the inverse tangent or arctangent of the imaginary part divided by the real part. In this case, we have tan inverse 2 over 1, giving us 63.43 degrees. Now that we have the r and the theta, we can use the information from here to write this complex number in polar and exponential forms. In polar form, the complex number is written as r cosine of theta plus I sine of theta, square root of 5 cos 63.4 plus I sin 63.4. And in exponential form, this is going to be r times e power I theta. So we get this form from Euler's formula that we discussed in class. So the r would be square root of 5 times e, do not forget your I, 63.4 degrees. And finally, we also plotted the complex number on a complex graph. Your complex graph is similar to your normal graph where you have your x and y axis. The only difference is that it has the real and the imaginary axis. So the number in focus was 1 plus 2y. We went 1 unit on the real axis and 2 units on the imaginary axis. And we represented the number in this form.